This is the Unit 1 test review for Pre-Cal Trig Fall 2021. If you've taken both opportunities on your test and would like to make some revisions before you ask for another attempt, or even do test corrections, you may use this review to take notes, make revisions before you move on to the next step. So for question number 1, we're asking, how does the multiplicity of a zero determine the behavior of the graph at that zero? And in this example, we're given a 5th degree polynomial. You'll see it underlined there. It has zeros of -4, but the multiplicity of 2. So we've got to pay attention to any of those zeros with multiplicity. So I'm going to just box that in. We have a 0 at 0. We have a 0 at 5 with multiplicity of 3. So I'll box that in. And we have a 0 at 7. So there's basically 3 things that can happen. So let's take a look at a visual representation of what that looks like. A 5th degree polynomial has zeros at -4 with multiplicity of 2. So let's focus in on that multiplicity of 2. A 0 with multiplicity of 2 is going to look parabolic. Okay. If we have a multiplicity, we're letting P stand for the multiplicity. Just a single 0 is going to go straight through the x-axis. And if we have a multiplicity of 3, then this is what it looks like. It's going to go through the x-axis after it kind of hugs the x-axis. Then it's going to keep moving through the x-axis. So with those 3 things in mind, let's take a look at that again. A single 0 is just going to go straight through the x-axis. For higher even powers, such as 2, 4, 6, and 8, the graph will still touch, so it's tangent to the x-axis, but it's going to bounce off. If you remember that lesson on extrema, it's going to bounce off and go in the other direction. But for each increasing even power, the graph will appear flatter. So as it approaches that axis, it's going to kind of flatten out as that power gets bigger and bigger. That's for even. For odd powers, this should be 3, 5, and 7. The graph will still touch and bounce off the x-axis and keep going through, but it will also appear flatter. So as that power gets bigger in the odd direction, it's going to flatten out more. Okay, so let's see if we can fill in the blank with those 3 things that happen. The graph of the function does what at the x-axis at -4? -4 has a multiplicity of 2. So it's going to touch and it's going to bounce, and it'll flatten out as that number gets bigger. Okay. If we have a multiplicity of 4, it'll get flatter. Of 6, it'll get even flatter, but it's going to bounce and turn around and go back in the opposite direction. So it's going to be tangent to. It's only going to touch at one place on the x-axis. Okay, now we're going to look at what it does at 0. 0 is a single multiplicity. So what's going to happen at 0 is it's going to go through the x-axis. It's going to cross straight through. And we also have a single multiplicity at 7. So it's going to cross straight through. And at 5, we have a multiplicity of 3. So that's going to cross, but it's going to hug. So that's what happened at 5. All right, for question number 2, we want the solution to the rational inequality. So take a look at that for a minute and think about how you would approach that. Now your first temptation or inclination may be to multiply everything through by x minus 2. But we don't know whether x minus 2 is greater than or less than 0. In other words, we don't know whether this is positive or negative. So we don't know whether that symbol is going, that inequality symbol is going to change direction. So my only option here is to move everything to one side. So I'm going to choose to move this to the left. So I'm essentially going to be subtracting 2 over x minus 2 from both sides. So I'll be left with 0 here, and I have 3x over x minus 2. And since I subtracted it from the right, I've got to subtract it from the left. And we don't have to worry about that inequality symbol flipping or changing. So we're left with 0 over here. Now I'll look at my denominators and I try to determine if I have a common denominator, which I do, so I don't have to find one and then multiply the numerator and the denominator so that I can combine like terms. I can just combine these numerators, 3x, and then we're subtracting 2, 3x minus 2 over x minus 2 is less than or equal to 0. Alright, so now I'm going to look at the numerator and the denominator, and I know that here at x minus 2, if that's equal to 0, we have a place on the number line that's undefined, and we cannot divide by 0, so we've got to eliminate that from our answers. So if x minus 2 is equal to 0, we solve for x, x is equal to 2. Now I'm going to look at the numerator. The numerator is 3x minus 2, and I'll set that equal to 0, but that's allowed. Okay, right here we can't let x be equal to a positive 2 because that's going to be an undefined solution. But we can have 0 in the numerator because 0 over any number is 0. So let's go to that purple equation and let's solve for x. So I'll add 2 to both sides. So 3x is equal to 2, and then divide by 3, and I'll get x is equal to 2/3. So how in the world do we put that on a number line, and how do we write our solution? So let me move over to the slide. Remember what we have. X cannot equal to positive 2, and x can equal to 2/3. So let's put that on our number line. All right, now that we have our number line and what x can and cannot be, let's put that on our number line. X cannot equal to 2. So I'm going to draw a circle and not fill it in where we have 2, positive 2. And then x can equal to 2/3. And 2/3 is right here. And I'm going to fill that in. That can be solid. All right, so we can have solutions here. I'm going to draw a vertical line through 2/3. I'm going to divide this graph into 3 sections, but it cannot be equal to 2 because that would be undefined. So I'll draw that as dotted. It's kind of like an asymptote. We are never going to have x equals 2 because that would give us an undefined number here. All right, so I'm going to look at 3x. Let's go back to our inequality. And I'm going to write it over here to the right. 3x minus 2 over x minus 2. Our inequality says it needs to be less than 0 or equal to 0. Okay, so that's this area over here. So a number that is less than 0 is negative. Okay, can be 0 as well. So we're looking for a negative number. So I'm going to evaluate in each of those three areas what happens when we substitute a number in. So if I look at this area right here, I'll take a number that's easy for me to use, and I'll just go up to, I can't use 2 because that's not a number I can use. We'll get a 0 in the denominator. I'll substitute in positive 3. So 3 times 3 is 9 minus 2 gives me, if I look at the numerator, gives me a positive number. And the denominator, 3 minus 2, also gives me a positive number. And a positive divided by a positive is a positive. Our solutions need to be less than 0, so I'm looking for a negative answer. So my solutions are not going to appear here. Let me look at the numbers to the left, and I'm going to pick 0. That's an easy one for me to work with. So 3 times 0 minus 2 is equal to negative 2. So I just am concerned about what the sign is. And then on the bottom, 0 minus 2 also gives me a negative number. And a negative divided by a negative is a positive. And I'm looking for answers in that range. And all the numbers in this range are going to act the same. They're going to give me positive answers. So that's not going to work. This area is not going to work. So let me check out this area here. I'm going to pick an easy number to work with, and that's 1. That's not part of my solution. I'm just going to pull it up here and say 3 times 1 minus 2 is 3 minus 2. That's a positive number. On the bottom, I have 1 minus 2. That's a negative number. And a positive divided by a negative is a negative. So I found where my solutions lie. They lie in this range right here. All right, so we write it as 2/3, including 2/3, with a solid bracket, all the way to 2, but not including 2. So I'm going to put that soft bracket. And that's how we write our answer. So I've cleaned it up a bit for you to look at on the next slide. All right, now we want to go to question number 3. How do you write this rational expression as the sum of 2 smaller rational numbers? So we're going to do this, we're going to approach this just the same way that we approach adding fractions. We're going to start off by factoring. I'm going to look at the numerator, and I cannot factor anything in 3x plus 4, so that stays the same. I'm going to simplify this as much as possible. And then I'm going to factor x squared minus 8x plus 15. So I want the factors of positive 15 that add to give me a negative 8. Now 3 times 5 is 15, and 5 plus 3 is 8, but it's not negative. But if I change both of those numbers to negatives, they do add to give me a negative 8. That's going to be x minus 3 and x minus 5. Double check my work. Tend to rush through. Okay. Oops, this is 5. All right, so now I'm going to write this as 2 smaller fractions that we're going to divide in these smaller pieces with the denominators of x minus 3 and x minus 5. I don't know what those are yet, so I'm going to use a variable, capital A for the first part and capital B for the second part, because it could be a simple number or it could be a more complex expression. And we want that to equal to our original fraction, 3x plus 4 over x squared minus 8, x plus 15. All right, now we know that if x minus 3 is equal to 0, then we're going to have an undefined number. We're going to have 0 in our denominator. So we can't let x equal to 3. Same thing for x minus 5, set that equal to 0, and x cannot equal to 5. So we're going to come back and look at these two considerations in a minute. But first we're going to multiply everything through by the lowest common denominator, or the least common denominator. We know what that is because we factored this original trinomial into x minus 3 times x minus 5. So we're going to multiply every term by the lowest common denominator. Now this is going to get real crowded if I pull it down, so just imagine I'm multiplying a times x minus 3 times x minus 5, but the x minus 3 is going to cancel, so we're just left with a times x minus 5. We'll go on to that second term that we're adding. Again, we're multiplying everything by the lowest common denominator. So here the x minus 5 is going to cancel, and we're left with b times x minus 3. And then here, that full factored expression here will expand to x squared minus 8x plus 15. So that whole thing is going to cancel. And we're left here with 3x plus 4. All right, now this is where I go back to what I said x cannot be, and I'm going to plug in a 3 into this equation everywhere there's an x and evaluate what happens. So 3 minus 5 is negative 2a, and 3 minus 3 is 0, so that's going to become just 0. So negative 2a plus 0 is equal to 3 times 3 is 9, and 9 plus 4 is 9, 10, 11, 12, 13. So we don't remember with 0, I can just ignore that and divide by negative 2, and a is equal to negative 13 halves. So I'm going to put this in the right answer location. Go back and look what we put a with. We put a with x minus 5, or what we put a over. We put a over x minus 3. So a is going to go right here. Negative 13 halves. And then that x minus 3 is the denominator. So that's negative 13 halves times 1 over x minus 3. Let me erase some of that. And then we'll try to do the same thing with that second number. So we're going to plug in 5 everywhere there's an x and do this again. If we do that, we're going to find the solution for b. All right, so this time we're going to put 5 minus 5 is 0, so this is going to cancel out. 5 minus 3 is positive 2 times b is equal to, put a 5 here, 3 times 5 is 15, plus 4 is 19. Divide both sides by 2, and b is equal to 19 halves. And I'll go back up to where I put b. Put b over x minus 5, and then we'll combine those in our answer. 19 over 2. Got a little bit messy. Let me rewrite that. So we have 19 over 2. Now I'm not checking my work, so if you find a mistake in my arithmetic, just follow the steps. Negative 13 over 2. You don't have to call my attention to it, but that's the process. So we're asked to solve the equation 4x, the square root of 4x minus 3 minus the square root of x minus 3 equals 3. So what I'm going to start out by doing is I'm going to add the square root of x minus 3 to both sides. I'm going to try not to rush through this because I don't want to make a simple mistake. So that's going to be 0 here. So on the left, I'm left with the square root of 4x minus 3. On the right, I have 3 plus the square root of x minus 3. I'm going to put this one first. That's just my preference. Now what I'm going to start off by doing is I'm going to square both sides. So when we square this radical, the radical is going to drop off. But on the right, I'm squaring a binomial, so I'm going to have to FOIL that out. First, outer, inner, last. Think about your algebra. All right, so when we square that radical on the left, the radical drops off and we get 4x minus 3 equals, the first term is going to be the square root of x minus 3 squared. So again, that's going to drop off and just give me x minus 3. I'm going to keep that together for now. And the outer terms are going to be 3 times the square root of x minus 3. Inner is going to be another 3 times the square root of x minus 3. So we're going to end up with 6 square roots of x minus 3. And then the last term is going to be 3 times 3 plus 9. Now I'm going to, we've got to keep this by itself. It will not combine with these constants, but 9 minus 3 is 6. So we have x plus 6 plus 6 square roots of x minus 3 on the left, on the right, I'm sorry. And then we have 4x minus 3 on the left. And I'm going to go ahead and subtract x and subtract 6 from both sides. So this is going to be 0, and I'm just left on the right with 6 times the square root of x minus 3. And then 4x, take away 1x is 3x, and negative 6 plus negative 3 is minus 9. Let me take a look at that for a minute and see if that looks correct. So I've got 3x minus 9, and I've got 6 times the square root of x minus 3. So now I have this radical over on the right, and it looks good, so I'm going to square both sides again one more time to get rid of that radical on the right. That's why I separated them. All right, so again, FOIL this out. If I FOIL out this binomial, I get 3 times 3 is 9. X times x is x squared. 9 times 3 is 27, and that's going to be a negative 27 because we're multiplying negative 9 times a positive 3. I've got two of those. So negative 27 plus another negative 27 is negative 54x. And then negative 9, last term, negative 9 times negative 9 is positive 81. On the right-hand side, we cannot forget to square the 6. So that's going to be 6 times 6, or 36. When we square this radical, that radical is going to drop away, and we have x minus 3. All right, now I need to distribute the 36 into this binomial. 36 times x is 36x, and 36 times negative 3 is negative 108. This is where I slow down, don't want to make any mistakes. Now I want to subtract 36x from both sides because I want the right-hand side to be 0, and I want to add 108. So those will cancel out and just give me 0 on the right. So remember, we subtracted 36x and we added 108. So on the left, we have 9x squared and 54 plus negative 54 plus a negative 36 is a negative 90. X plus 108 plus 81 is 189. I'm just trying to double check, guys. Okay, so now we have an equation that we can factor. So let's look at this. 9x squared minus 90x plus, what was that, 189. Now notice, I hope, I'm going to get my calculator out, that all these are divisible by 9. Make it much easier to factor. 9 divided by 9 is x squared. Negative 90 divided by 9 is negative 10x plus 189. Let me double check with my calculator. 189 divided by 9 is 21. So now I'm going to look at the factors of 21 that add to negative 10. And we've got 1 times 21 and 3 times 7, but those both need to be negative to add to give me that negative 10 here. So it factors into x minus 3 times x minus 7 equals 0. So we have a solution at x equals 3 and x equals 7. You want to plug those back into the original equation to check to make sure that there are not any extraneous solutions. Question number 6, we want to know the graph of the function. Now the question is going to give you 2 or 3 or 4 graphs to look at, so don't make this harder than it is. I want to look at where the denominator is 0. We're going to have an asymptote. It's going to be, there aren't ever going to be any x's that touch at x equals 2, because that would give us a 0 in our denominator. So let me look at my functions, and here's 2, and here's 2, and here's 2. But if I go up this direction, we would have a solution here. So this is not going to be the graph of my function. Same thing here, across here. So I've got to eliminate that. But here, if I draw in my asymptote, okay, the graph is going to approach from the right, and it's going to look like it touches. But if you zoom in, if you're checking on Desmos, you can use it to check, but you shouldn't be using it to find a solution. You can be using it as a tool to help you, because sometimes it looks like it's touching and you've got to really zoom in to make sure that you see what's happening. The behavior is it's going to get really, really close, And the more you zoom in, you'll see it's not actually touching that asymptote. So this first graph is going to be the graph of the function. Right here. Okay, question number 7. What are the coordinates of the hole in the graph of the function? So we have a numerator and a denominator that we can factor. So use your algebra skills to factor this out into x minus 4. The numerator is x minus 4 times 2x plus 3. The denominator is x minus 4 times 3x plus 1. Okay, right here, if x minus 4 is equal to 0, we'd have an asymptote, or we'd have a hole in the function at x equals 4. So that would be our x value. On our coordinate plane, that's just our x value. So we'd have an asymptote here. I want to know what the y value is that goes in here. To find that, you're going to plug in 4 right here. This is going to cancel out. 2 times 4 is 8. 8 plus 3 is our numerator, and 3 times 4 is 12 plus 1. 12 plus 1 is our denominator. 8, 9, 10, 11, 12, 13. So we have a hole in the graph at 4, 11 13ths. Question number 8. How can you determine if x plus 3 is a factor of f of x equals negative 3x to the 4th minus 2x cubed minus 4x plus 10? So what we do is we're evaluating, if we set this equal to 0, we're evaluating f of negative 3. Right, so we're going to take that negative 3 and we're going to plug it in to where x is. And we're going to see what the value would be. So negative 3 to the 4th power is going to give us a positive 81. We're multiplying that times a negative 3. And then we move over here, we have a negative 2. Now that negative 3, when we cube it, we're still going to have a negative number. So we're going to have negative 27 times a negative 2. I'm going to run out of room right here. Plus negative 2 times negative 27. Let me pull that down. Negative 3 times 81. Go ahead and multiply. I'm going to go ahead and multiply that out. It's negative 243. And then negative times a negative is a positive 108. All right, so that's just the first 2 terms. Let's move over here. A negative 4 times a negative 3 is a positive 12. And then we have our 10. So get your calculator out, add those numbers together. When I added mine together, I got negative 113. And I'm kind of rushing through this, so double check me if you get something different. But I know that this x plus 3 is not a solution. The way that it's written on the test is not a factor. if I had substituted, if I had evaluated f of -3 and I had gotten 0, then I could say, yes, it is a factor. All right, now we're looking at an equation to determine the end behavior. And if you remember and you've been to class and you've checked your email, I've asked you to take notes to carefully look at this and evaluate what's happening. So we're going to look at only the leading terms. Let's check to see if this is in order, descending order. We have an x to the 4th, an x to the 3rd. We don't have an x squared. But yes, this is our leading term. So that leading term, the coefficient is negative, and the power is even. So think back to your notes. Keep this in mind. Move over to another slide, have some more room. Let's look at that closely. What does that behavior look like? Negative, even. Negative, even. It's going to look like this right here. So as x gets smaller, f of x or y gets smaller. As x gets larger, y still gets smaller. So it's going to look like this. Something's going to happen, but it's going to go down and down. So how do I write that? Remember what's happening. Get that by our leading term. As x approaches infinity, what happens to f of x? In this case, it also approaches negative infinity. I think I said that wrong. As x approaches negative infinity, f of x, the solutions are also going to approach negative infinity. As x approaches positive infinity, f of x approaches negative infinity. Make that correction, that should be negative. Question number 11, we want to know the domain. This time we're not looking at the solutions, we're looking at everything that x could possibly be. So we're going to start by factoring the numerator and the denominator. If I look at the numerator, there's not much I can do to factor it. It's just going to be x minus 4. But I can factor the denominator. So if you want to pause right now and take some time to practice your factoring, you may. All right, so if we factor this denominator into x minus 4 times 2x plus 5. Okay, so I can see that I have a factor that's the same as the numerator. So I can take this and look at it and evaluate if x minus 4 is equal to 0, then x would equal to 4, and we would have an undefined solution. So there's going to be a hole there at x is equal to 4. So on my number line, let me just circle that and leave that open. Same thing would happen here at 2x plus 5. All right, if that's equal to 0, we're going to have another hole. Subtract 5 from both sides and divide by 2. So we'll have a hole at x is equal to negative 5/2. Divide 5 by 2, we get 2 1/2, so negative 2 1/2 would be about right here. So I'm going to have to circle that and leave that open. So we cannot let x be 4 or x be negative 5/2. So but it can be everything else. Everything else is going to give us some kind of solution. So we can have numbers here, to the left, to the right, and in the middle. but we cannot have these two. So how do we write that? That's our only challenge. Okay, we write it this way. We're going to start over here at the left, and we have negative infinity. We're including negative infinity to negative 5/2. But I'm going to put a hard bracket there because that's not part of our solution. All right, we're going to unite that. We're going to have a union with this area here. And that's going to be, do not include negative 5/2. And then we're going to go to 4, and we're not going to include 4. X cannot be negative 5/2 or 4. And we're going to have a union with this last part of the graph, 4 to positive infinity. And we're including all those numbers there. So this is our solution, and that's the way that you write it. So that's leaving out these undefined areas. All right, now we're going to graph the solution to the inequality, and I'm going to need to do something with that radical. So before I start, I'm going to divide through by a -2. Now that's okay as long as I remember to flip my sign. So that's just going to become a positive square root of x plus 5. The sign's going to flip. -6 divided by -2 is a positive 3. Then I'm going to square both sides, and I get x plus 5 is greater than 9. Subtract 5 from both sides, and we get x is greater than 4. And we simply draw our number line, and it's not going to include 4, but it's going to go to the right. It's going to be greater than 4. All right, for question number 13, we have a word problem. It says Hiram determines the remainder of x to the third power minus 7x minus 6 over x minus 4. So he's dividing the denominator into the numerator using the remainder theorem. How does he proceed to the correct answer? So if you practice and you go through your notes, you know what happens here. He's going to evaluate the numerator when the rational expression when x is equal to 4. Okay. Now if you put 4 into the numerator, you'll get 4 to the third power minus 7 times 4 minus 6. Okay, 4 to the third power. Let me get my calculator out. 4 times 4 is 16 times 4 is 64. Minus 7 times 4 is 28. Minus 6. Go slowly. 64 minus 28 minus 6 is equal to 30. So that would give us the remainder of the division if I divided this into this. All right, we're almost done. Question number 14, we want to find the roots of this equation. So we would take this and we would need to factor it. And this factors into x minus 1 times x plus 2 times x squared minus 5. I'm sorry, x squared plus 5 equals 0. So we have a single solution here, or a root, at x equals 1. We have a single solution here at x equals -2. Okay, but if I evaluate this and set it equal to 0, then we have to really look carefully at what happens. So x squared plus 5 equals 0. When you subtract 5 from both sides, you get x squared equals -5. Now when you take the square root of x squared, you just get x, which is good. We want to get x. But if you take the square root of the right side, you're taking the square root of a negative number. That -1 times 5. We can take the square root of -1 and write it as I. It's an imaginary number. So x is equal to plus or minus I times the square root of 5. Okay? So now we have two more imaginary solutions. Positive I times the square root of 5. And negative I times the square root of 5. Okay, and we look here, x to the 4th power, we should have 4 solutions. We have 2 real and 2 imaginary. All right, the last question. We want to know what the slant asymptote of this rational function is. To get the slant asymptote, we're going to divide the numerator into divide the numerator by the denominator. So let me set that up. And I can find the slant asymptote if we have a leading term that's to the 3rd power on the top, and we have the leading term to the 2nd power if there's 1 degree difference. So I'm going to divide 6x to the 3rd plus 4x squared minus 6x minus 5 by 2x squared plus 3. Now I'm missing that x term, so I need to write this as 2x squared plus 0x plus 3 before I start my division. I'm dividing that into 6x to the 3rd plus 4x squared minus 6x minus 5. So I'm going to look at this term. 2 goes into 6 3 times, and I need to multiply another x to x squared to get x to the 3rd. So I need to multiply by x and a 3x. So 3 times 2 is 6. X times x squared is x to the 3rd. All right, take that 3x and multiply it to 0x, and you get 0x. Take that 3x and multiply it to 3. We're taking that and multiplying it to each of these terms, and we get 9x. We're going to change the signs of everything. Of course, 0 doesn't, it's neutral, doesn't have a sign. You don't need to change anything. And we get 0 here. Bring down the 4x squared. And a -9 plus a -6 is a -15x. And then bring down the -5. All right, we're going to go one more term. Now we're looking at what do we multiply 2x squared by to get x squared. That's just going to be 2. We multiply by a positive 2. 2 times 2 is 4. 2 times x squared, x squared. All right, and then we get 2 times 0x is 0x, and 2 times 3 is 6. And we change everything to its opposite sign and add, and we get -15x plus 1 is the remainder. This, we don't need to worry about the remainder. This is our slant asymptote. Y equals 3x plus 2. We would graph that line, and that's where f of x, the solutions would never touch. All right, I hope this helps you. Thanks for coming, and good luck on your test.